S1180, Aurora kinase can also phosphorylate. So I'm going to tell you a little bit more about both of these kinases. Protein kinase A, PICO-A, is known to phosphorylate a wide range of targets: nuclear transcription factors, membrane transporters, and ion channels. A rise in the cyclic AMP in the cell leads to activation of PICO-A by releasing its catalytic subunits. So in these experiments, we decided to activate PICO-A by alpha 8 bromo cyclic AMP, which is a non-hydrolyzable CAMP analog, and we decided to inhibit PICO-A by the concerted action of H89 and protein kinase A inhibitor. So Aurora kinases. There are three Aurora kinases, Aurora A, B, and C. They play vital roles in mitosis. And here we have a little Aurora kinase A and Aurora B. They both can self-phosphorylate. They can also phosphorylate histone H3, which is involved in the nucleus. Aurora A is also found in the cytoplasm and associates with the centromere. Aurora B mainly stays in the nucleus and associates with the centrosome of chromosomes. And we inhibited Aurora. We use a pan-Aurora inhibitor, which is VX608, which would inhibit all isoforms of Aurora. And I'm going to go through some results of these second set of experiments, as before. Here we've only taken wild type, S89 and S1180, and either stimulated PICO-A, inhibited PICO-A, or inhibited Aurora. We also did a double PICO-A stimulation and inhibition. I'm going to go through these results for you. Here we first have PICO-A stimulation. We see that wild type is not affected by PICO-A stimulation, whilst S89A exhibits a reduced recovery rate. This is relative to their own control condition, whilst in S1180 exhibits an increased recovery rate upon PICO-A stimulation. When I inhibited PICO-A, we see that these recovery rates are quite similar, no difference statistically. Simultaneous PICO-A inhibition and stimulation resulted in reduced recovery rates for all clones. This, I believe, is more an effect of stressing the cell than any. And then finally, Aurora inhibition did not affect wild type or S89 clone, but it really increased the recovery rate of S1180. Then I took these same results and then analyzed them per condition relative to wild type to assess the specific effect. So here we have S89 and S1180. Here we see that they are relative to wild type. So in there are two control conditions, which are DMSO and acetylnitrile in both conditions. S89 exhibits no difference to wild type in DMSO control, but in the second control it has a reduced recovery rate, whilst the opposite is true for S1180 clone, where, as we saw before, in normal conditions it exhibits a slower recovery rate relative to wild type, but this disappears in the second control when acetylnitrile and ethanol is in place. And then the next three bars of each graph represent the PICO-A modulation. First, we have for S89 that stimulation of PICO-A reduces, S89 exhibits a reduced recovery rate relative to wild type, so wild type is stimulated. Upon PICO-A inhibition, there is no difference. And simultaneous, you see an increase, but as the error bars are quite high, I don't include anything from that. And for S1180, it's important to note that there's a difference. When you stimulate PICO-A, we see a similar recovery rate to wild type, whilst in S89 it was reduced. Inhibition of PICO-A also means S1180 becomes a bit quicker. That's the PICO-A results. And then last but not least, we look at the Aurora inhibition. And here we see in both cases there is no significant difference to wild type, let's say, when you inhibit Aurora. So these results combined led me to propose a model for what it might be happening. Here we have MBC1 again with the two sites. First, my results indicate that PICO-A phosphorylation on Ceron 89 might have a stimulating, activating effect on MBCM1, whilst phosphorylating S1180 has a inhibiting effect. This is why when we saw the wild type cells, there is no effect of PICO-A stimulation. It might be because they balance each other out, so to say. And then for most site-specific, for these two at least, a phosphoryl effect. It might be through another mediator or another site, but when Aurora is not inhibited, for some reason there is like a inhibiting effect. So when Aurora gets inhibited, NBC1 has a quicker recovery rate, always, across the 3 clones. That was that part. So here are my conclusions for the whole project. For the first part, since the successful GFP constructs were made and the procedure was done and sent for an MS analysis, we should receive some novel candidates, exciting candidates for N-terminal and BC1 binding interactions. For the second part of the project, these RMBCN1 variants expressed in HEC293 cells, I see lower recovery rates for S1180 and S89 clones relative to wild type. They are slightly sensitive to S0859, which was the general MBC inhibitor, yet they were highly sensitive to DIDS, which was the non-specific bicarbonate transporter inhibitor, which generally has been described as not inhibiting MBCN1. For the PQA results, I believe it indicates that phosphorylation on Serin 89 stimulates MBCN1 activity, whilst phosphorylation on S1180 inhibits MBCN1 activity. And the Aurora results do not suggest any direct effect, both via either S89 or S1180, maybe via other sites or another interacting partner, and inhibition of Aurora leads to increased recovery rate of MBCN1. And then future perspectives. For the first project, once the mass spectrometry analysis is carried out and the results are obtained, you would screen the results for likely candidates. You would choose which ones you think are best. You would do some co-IPs to confirm in vivo binding of MBCN1 of this protein, and also co-immunofluorescence to visualize that they're localized in vivo in the same areas. And then furthermore, you would carry out knockdown and overexpression experiments to ascertain the effect of this interaction. For S1180, also S89, we still have to elucidate the mechanism behind the lower recovery rates observed in normal conditions, which was attempted here. I would also investigate the DIDS effect further, because in most cases, MBCN1 has been described as not being inhibited by DIDS. So is this a cell-specific, a splice variant-specific, or an interacting partner? It has yet to be elucidated. And the feedback for the protein kinase A's in Aurora experiments. Repetition of experiments are necessary to confirm or dispel the proposed model. A double S89A and S1180A mutant would be necessary, would allow you to see what effects are more. Maybe usage of other PKA activators and inhibitors. I must say that in my experiments, I was unable to actually, through Western blot, confirm if the kinase modulators actually had an effect on the kinase as hypothesized. So I can't be sure that I actually affected protein kinase A or Aurora, unfortunately. And then, last but not least, the 2 other phosphorylation sites, they've been identified, so further elucidation of what these phosphorylations have on MBCN1, if it's proper trafficking, of binding of another partner in another cell type, is yet to be elucidated. Finally, much is yet to be elucidated about MBCN1, and thank you for your attention.
Let's reconvene in a few minutes. Just maybe somebody should open the door so nobody faints.